Hi, Josh here, and you're watching 610BOB's Builds. Today, I got a hot build for you. It's a powder coating oven. To powder coat my rims and axle, I need a fairly large oven. Since this oven is only going to reach 400 to 500 degrees Fahrenheit, this won't be very complicated. I made the inner box out of 18 gauge sheet metal and the outer covering out of 22 gauge metal. To start the inner box, I cut a piece of 18 gauge sheet metal to the appropriate size and bend flanges on the edges. These flanges will help welding. After cutting and marking my bends, I bend the sides. I first bend a lip to assist welding, then I bend a corner to form a half of a rectangle. Yeah, when I said that I cut the bottom to the appropriate size, I lied. I messed up a little. I forgot to add the side flanges onto the width of the bottom, so I flattened them out to make the bottom fit. Then I weld the inner box together, which takes a really long time. Figuring I was going to be resting heavy objects on the bottom of the oven, I bent some sheet metal into a U-channel and tacked them to the bottom of the inner box for bottom supports. Getting tired of welding and wanting to avoid more warping, I finished the installation of the bottom supports by riveting them in place. The oven will obviously be insulated, so I bent some more C-channel and welded it to the top of the inner box. This channel will help support the insulation and support the outside paneling. It will also give a spot for the lid to sit and seal against. To continue building the outer shell, I weld in corner pieces and their bottom supports. Now for the casters. I weld two pieces of C-channel that I had laying around to form a large box. I didn't want to put the casters directly on the inner box. This could overheat the casters. Using this box design, air will flow around the sides, cooling them off, and preventing the heat from transferring into the casters. After marking and drilling the caster mounting holes, I rivet the caster mounts to the bottom of the inner box. After bolting the casters on, I start work on the lid. After cutting the sheet metal, I bend four sides, making an open box. I do this again to make a second box. I then rivet corner pieces to one of the boxes. I will later insulate and place the other box on top, then screw the sides together, forming a closed box. I then bend more C-channel pieces and rivet them to the inner box. This channel will support the insulation and support the outside panels. It will also help reinforce the sides of the inner box a little. I also throw in the heater elements and the heater element shields. The shield should help reflect more heat into the oven. The heating elements are just replacement elements for a kitchen oven. The element pokes through the bottom of the oven for its electrical connections. Now to insulate, I'm using rock wool. It's a fire-resistant insulation. It's easily obtained from Lowe's or Home Depot. Installation of this insulation is easy. Just cut, install, cut, install, cut. Well, you get the idea. To control the heat, I install an oven thermostat. I mount the thermostat to a piece of sheet metal and screw the metal to the oven. I then drill a hole and poke the sensor through. I make a box and install it on the bottom of the oven to hold the relay for the elements. I wired the elements to the relay using heat-resistant wire. I wire the thermostat in so that it controls the relay. The lid doesn't have any hinges, so I installed two handles so that I can more easily place and remove the lid. And now for the stuff I got wrong. Welding the inner box was, well, stupid. I should have made a frame by bending sheet metal into angled steel and then just riveting the sides on. Welding just made a mess and took forever. Also, that oven thermostat stunk. The set point wandered way too much. Not to mention, as the thermostat heated up, the set point would go down. So I brought the oven into the 21st century by using a digital thermostat. I got this one off of Amazon. It came with this digital relay. This allows the thermostat to pulse the heating elements and maintain a temperature within a few degrees. And the oven is done. Subscribe to see the oven in action. When I'm ready to cut, I engage the lead screw by pushing this lever down. This causes the carriage to move forward. When I'm ready to stop and go back, I pull the lever up once. This stops the lead screw, allowing me to pull the cross slide back.